made easy here because I honestly believe that dimensional analysis is the best way to go when it comes to dosage calculations. The biggest benefit I see to dimensional analysis is it means that you only have to know one process. Other ways teach you multiple different formulas to learn. And while we think we've done a pretty good job breaking that down for you in the basics of calculations lesson, I still believe that having only one way to do things every time is way better. The other benefit is that dimensional analysis works for all types of calculations: simple, complex, weight based, lots of conversions, or the super straightforward ones. It still works. And there's no need to do any kind of separate rounding or separate conversions in the middle of the process. Everything happens with one final calculation. Now, we're going to talk you through the process of dimensional analysis with the same problem we used in the basics of calculations lesson. And then I'm going to show you how it works for simple and complex problems by working a few out for you. In the other med math lessons on the different types of problems, we're going to use this method because honestly, we feel like it's the best way to go. So when you start dimensional analysis, you always want to start with what you're looking for and then build your equation from there. So let's read this problem. The provider orders 60 milliequivalents of potassium chloride IV to be given over 4 hours. The bag contains 100 milliequivalents in 1 liter of NS. What is the rate you should set on the pump? So first things first, identify our variables. What are we looking for? Well, setting a rate on an IV pump always means milliliters per hour. So we're going to write that here, and we're going to put an equal sign because we're going to be setting up an equation. Okay, step 1, start with what you're looking for. Now, once you've got that, the next step is to transfer the units across. So in this case, we're going to take the milliliters from the left, we're going to shift it directly over to the right-hand side. This is going to help set us up for success so that we know we end up with the right units in the right place. Once we've transferred our units over, the next step is one that you're just going to kind of keep repeating. Insert what you know, convert if you don't. What I mean by what you know is if you have anything provided for you in the problem about those units. So, does the problem say anything about milliliters? Actually, no. So, if you don't know anything about that unit, we use a conversion. So, do we have anything in here that we could use as a conversion? Well, yes, we do. We have liters. So, we're going to convert. 1,000 milliliters is equivalent to 1 liter. Okay, now we're going to repeat this process of transferring units across and then inserting what we know, converting if we don't, until we cancel enough units to get to our desired result or what we're looking for. Remember, this is what we're looking for. Remember that if you see the same units on the top and the bottom on this side of the equation, you can actually cancel them out. So we've already got our first 1,000 milliliters is equivalent to 1 liter. So now we're going to transfer the liters over to the top, and then we're going to insert what we know. Well, what do we know about liters? We know that 1 liter is equivalent to 100 milliequivalents of potassium. So 1 liter, 100 milliequivalents. This is what we have been provided. All right. So repeat the steps. Transfer the units across, insert what we know. What else do we know about milliequivalents? Now, sometimes I'll like to cross things off as I use them so that I don't double anything up. So I've already used this milliequivalents. So what else do I know? Well, I know that I want 60 milliequivalents of potassium over 4 hours. So 60 milliequivalents is going to go over 4 hours. Okay. Now I can cancel the liters. I can cancel the milliequivalents because they're one on the top and one on the bottom. Now I'm going to look, do I have my desired result? Well, I've got milliliters on top. I've got hours on the bottom. So now I have what I'm looking for. So everything lines up. We're good to go. Now here's the fun part, and here's why I love this so much. Now you only have to do one calculation. So remember this phrase: multiply across the top, divide across the bottom. Multiply across the top, divide across the bottom. So you're going to go into your calculator and you're going to type this: 1,000 times 1 times 60. Now divide across the bottom, divided by 1, divided by 100, divided by 4. Okay, do you see that? multiply across the top, divide across the bottom. When you press equals in your calculator, you're going to end up with 150. Remember, our last step is always to verify. So we insert the right units, in this case, milliliters per hour. We round if necessary, and then we ask ourselves if this makes sense. In 1 liter, there's 100 milliequivalents. We're only giving 60, so in that 4 hours should be less than 1,000. 150 times 4 hours would be 600, so this all seems right to me. So a recap of these steps. Start with what you're looking for, transfer units across, insert what you know, convert if you don't, and then repeat those steps until you cancel enough units to get what you want. Now, if you've seen the basic calculations lesson, you know I give 4 steps: identify, convert, solve, and verify. These 4 steps here are your identify and convert steps. Step 5, multiply across the top, divide across the bottom. That's your solve step. And then the last step is always to verify. Same general process, just a little different in the execution. Now, I want you to see how amazing dimensional analysis is. It works for super simple and super complex problems. Let's look at a simple one first. The provider orders 650 milligrams of acetaminophen PO times 1 dose. You have 325 milligram tablets on hand. How many tablets should be given? All right, start with what you're looking for. What we're looking for is tablets per dose. Now, you'll see why I add the per dose part here in a second. Then we transfer our units across, so tabs. Now, what do we know about tabs? Well, we know that 1 tab is 325 milligrams, right? Great. Now we transfer units up again, milligrams. What else do we know about milligrams? Well, we already used this one, so we're going to use this one. 650 milligrams in 1 dose. So now we cancel the 2 milligrams because one's on the top and one's on the bottom. And what are we left with? We are left with tabs per dose. So have we gotten to what we want? Yes, we have. So now multiply across the top, divide across the bottom. 1 times 650 divided by 325 divided by 1 equals 2 tabs per dose. Now, some of you that love math are probably thinking, this girl is crazy. She keeps multiplying and divided by 1. You don't have to do that. You are absolutely right. You can leave the ones out mathematically, but I prefer to keep them in because it makes sure that I don't accidentally skip over something as I'm multiplying across the top and dividing across the bottom. It's just a personal preference. All right. So now we're going to look at a more complex problem. We have a whole lesson on complex calculations, so don't let this confuse you too much. I just want to show you that it's possible to do. Then go check out that lesson for a bit more of a talk through. Okay, the nurse notes that the patient has dopamine infusing at 39.3 milliliters per hour. The bag says 400 milligrams in 250 milliliters. The patient weighs 192 pounds. How many mics per kilo per minute is the patient receiving? So step 1, start with what you're looking for. In this case, we are looking for micrograms per. Now here's a tip here. If you have 2 pers, they both go on the bottom. Mics per kilo per minute. Okay, only one goes on the top. So step 2, transfer my top units across. Micrograms. Do I know anything about micrograms? Well, actually, nope. I need to convert. So I have milligrams. So I'm going to do a conversion factor. 1,000 micrograms equals 1 milligram. And then I'm going to transfer the units up. Insert what I know. 400 milligrams is in 250 milliliters. All right, cancel milligrams. Transfer units up. What else do I know about milliliters? Well, I know that it's at 39.3 milliliters in 1 hour. All right. Am I where I want to be yet? Nope. I'm at micrograms per hour, so I'm not quite there. I want minutes, so let's do another conversion. 1 hour is 60 minutes. Now, I've got my micrograms, I've got my minutes, I'm missing my kilos. I happen to know that I want the kilos on the bottom. So I'm going to do a conversion. 1 kilogram is 2.2 pounds. and the patient weighs 192 pounds. Now I can cancel the pounds. I'm left with micrograms, minutes, and kilos on the bottom, which is exactly where I want to be. When I go to put this in my calculator, I'm going to do 1,000 times 400 times 39.3 times 1 times 2.2, divided by 1, divided by 250, divided by 1, divided by 60, divided by 1, and divided by 192. When you do that, you're going to end up with 12.0083 repeating. Now, we typically only round to the 10th place with milliliters per hour, so this is actually going to round to 12. We add our units, micrograms per kilos per minute. Ask ourselves if that makes sense. Now, you could do the problem in reverse to see if you get 39.3 milliliters per hour. I also like to just think about a normal dose, which for dopamine happens to be 5 to 20. So 12 fits right in there and it makes sense. Again, check out the complex calculations lesson to see more problems like this. But I just wanted you to see that with this one process, you can even solve some really complex problems. So remember, the benefits of dimensional analysis is that we can do our calculations the same way every single time, and it works for every type of problem from simple to complex. Ultimately, though, we want you to choose the method that works for you. It is all about being safe and getting the right dosages for our patients. Make sure you check out the individual lessons on oral, IV, injectable, and complex med math calculations to see more examples worked out for you. All right, guys. Make sure you check out the cheat sheets attached to this lesson as well and the questions. Now go out and be your best selves today. And as always, happy nursing.